All right, we're good to go. So first thing I want to do, let's start with our parent graph. Let's start with the square root of x graph. Okay, x is your input, y is your output. Yep, do we have an extra copy of the notes right up there? I think Isabel needs one. Yeah, should be right there.
Yep.
Yeah.
And then just so refresh.
Okay. So the first thing I want to do is let's just kind of, we'll type this guy in. Okay. So on the graphing calculator, I want you guys to see this here. Okay. You go to the y equals grid, and we type in second x squared, and then put x, and then hit graph, and you got your standard Swiss graph. So we're trying to produce that basically. So the graphing calculator do it in like 2 seconds. Okay. But we understand that if I hit second graph, the table is significant because the table tells us where the domain is limited. You see what happens when I have -1? You get error. Do you guys know why that's an error? What if I plug -1 in for x? Can you take the square root of a negative number? No. Okay. So if I look at my table, let's copy some of these nice numbers down. Like 0, 1, and 4 are pretty numbers. Okay. 0, 1, 4 work out pretty good. You can kind of scroll down the table.
Try to find like whole numbers.
Yeah,
Get a
so
graph.
whole numbers that work well, like 9, 3 is a pretty number.
Yeah.
Okay. And so, you copy those down, you got your graph. I mean, we've been doing this like even with any function we've been dealing with, you can kind of see, hey, what's going on with those graphs? At 0, it was just 0. Okay. Now, I want you guys to understand where these came from, though. If I didn't have a graphing calculator, if I plug 1 in for x, okay, what's the square root of 1? That's how you got 1 for y. All right? If I plug 4 in for x, what's the square root of 4? 2. Right? If I plug 9 in for x, what's the square root of 9? 3. So there's always a relationship between the input and output. Okay? And so let's just plot this. You got 0, 0, 1, 1, 4, 2. Okay, just like Battleship, right? X, Y coordinate points, plotting them on the plane. And then 9, 3. And so we get that kind of swish graph we were talking about. You got this arrow on the right side. So it starts here, and it goes forever in this direction. So you guys tell me what the domain would be? What's the domain? What are the x values? I start here and I go to the right. So what x values am I using? Do I use any negative x values? No. So what would I say? All x values greater equal to 0. That's the domain. Now, you can also see it from what we did yesterday in class. You can see that if I take what's under the radical and I show that it's greater or equal to 0, there's your domain. All right, so you can get, whatever's under the radical has to be greater or equal to 0. Okay? And so there's, you get it both ways. And so now we're going to add this concept today. We're going to look at the range now a little bit. Okay? If I start here and go to the right, what's the range? The y values. So do I use any negative y values? No, it's always y values greater than what? Not 1, greater than 0. Greater or equal to 0. Okay? Now, I want you guys to understand that this notation right here is the same as this. 0 to infinity. I go from 0 on the x to infinity on the x direction. So the bracket on the left means bounded. This thing on the right means unbounded. Okay? You may see that occasionally, but if we just give me this one, that's fine. but that does pop up on occasion. That's an interval note way to express it. Okay? So the range you could also express from 0, it's bounded at 0, and it goes up to infinity. So it's 0 to infinity in the y direction. You could draw it like that too. Okay? So just be aware that that might pop up. Okay? But if you give me these, that's fine. That's the same concept. Okay? All right, let's take a look at another graph here. Okay, so we were playing around with the transformations right in the beginning of class. What's the minus 2 inside the radical going to do to the switch graph? Not flip it. It's going to move it how far? 2 to the right. So I already know this is that same graph. Just move 2 to the right. Okay, just by looking at that thing. But here's what we can do. We can say, all right, well, if I take my radicand and show that that's greater or equal to 0, I'll get the domain of that graph very, very easily, right? So what would I do to get x by itself? Add 2 to the right. Okay? So notice there's your domain right there. X is greater or equal to 2. So we got that part. We don't know the range yet, okay? But you probably could, you'll see a pattern here. If we type this in, and actually I want you guys to do this with me real quick. Just make sure you know how to use your calculators. I mean, this is consistent skill, guys. All right, so go open your graphing calculators. All right, and what I want you to do is hit the y equals button and type in this root x minus 2. Okay. So you got to hit second x squared to get the square root thing to pop up. Okay, so do that now, guys. You don't want to be lost when this is assessed. You want to make sure that you have this now. Okay, so type it in, and then type x minus 2 under the radical. Okay, can't pay attention here, okay? Follow along. And then all we do is hit graph. So hit the graph button in the upper right hand corner. There's the same graph, shifted 2 to the right. Okay? All right, are you seeing that?
Yeah.
Okay. So to get the table, all I do is hit second graph. All right? And what we can do is we can start from that start. See how there's error at 1? Right? So you know that the lowest x value you can use is 2. So we're just going to copy the pretty numbers on that table. So we got 2, 0. Another one is 3, 1. Just copy the pretty numbers. Sometimes they're not pretty, but at 6, 2, I got another pretty one. And really, you only need a few. And then 11, 3 is another pretty one. Okay? And then you just copy them on your graph. Alright? Just like Battleship. X, 2, Y, 0. There's your location. 2, 0. 3, 1. Over 3, up 1. Right? Over 6, up 2. There's our next one. And then 11, up 3. That's off the grid, so we'll just leave those 3. And here's your graph. Arrow on this side. And this is our starting point right there. So you see how from the graph, what's the domain? Just looking from the graph. What would that domain be? Everything above, nope, not the domain, guys, not the range. All x values greater than what? 2, right? And we already found that from our algebra, right? So you could write that like this. You could write it as bounded at 2 and then goes to infinity. That's one way to express that. Or you could write it like this. Okay? All right. Can you guys tell me what the range would be? The y values? Go ahead, Braxton. What would that be?
0.
Yeah, so, well, it just, you see how it never goes below the x-axis. So it's all y values greater than what? 0. Very good. Greater or equal to 0. Or you could write it like this. You could say from 0 to infinity. okay, as an interval. Okay? All right, I want you to jot something down on your notes. This is important here. The K, that's your vertical units. Okay? The H represents your horizontal shift. And then the A value out front, we're going to write this down, that makes it steeper. The bigger the A, the steeper the swish. Okay? So this steepens the graph. Okay? And then if your A is negative, it flips it over the x-axis. Alright, so just keep that in mind. If, we'll write that down, if A is less than 0, if it's negative, alright, then the graph is reflected over the x-axis. Okay? So those were the things we just explored in the beginning of the hour, essentially. And I'm just kind of annotating that in your notes. So you're kind of able to see that. Okay? So remember, when that A, like for instance, if I put in this equation here, if I put a negative out front, what would this swish graph look like? If I put a negative out front, would it go up or down? It would go down. Okay, and so that's the significance of the A value out front there. Okay, so remember, this right here is kind of transforming, this form is transforming our parent graph. Okay, all right, so here's what we're going to test. All right, I want to see that you are able to do some basic graphs. All right, so I want you to do these two graphs on your own, C and D. Okay, and I want you to give them a shot. Use your graphing calculator to establish the domain and range, and obviously be able to do your plotting of those points. Okay, so do that right now, please. Okay, so it's just a matter of being able to use it. Is it too dark, guys? If we could maybe pop the lights on for a second.
It's good, it's fine.
All right, no problem.
That's rain coming through, it's dark.
Yeah, that's good. If it's too dark, let us know. I can pop one of those on.
Alright, I'm not good.
But it's important you guys are able to do these on your own.
So C
C and D, okay? Two graphs on your own.
and C and D.
Okay, use that graphing calculator, guys. This will save you a lot of time. If you don't have it, you have to do it manually, right? Kind of do it to figure out what the output is. Show your steps on there. It's important, okay? One goes on a little dark. Maybe just pop one there. That right there. There we go. Sorry about that. Okay. Yeah. Well, I think you're outside. This is inside. Put them down. So basically a swish graph. Move down to. So what you gotta do is hit the arrow. You get the circuit accelerator.
Yes.
Hit the arrow. Hit the way.
I saw it, so
Because you can see what's on the grass, just that part. Right? Now the line would not be that. Any greater, you'll see if you graph it, it'll be about that. See how it's above the so it'll be all Y values greater than negative. Okay? Yep.
Will you dare challenge me?
Yeah. Very good.
I'll go 11 for me.
Good, just sketch it, guys, use that table to your advantage, okay? Good job, Trey. I've seen some good steps here. Take your time, guys. You get two of these right, you're gonna get any of these right. And you just gotta know how to do it. All right? Really doing right. Now, if you did that +3 outside, you do that +3 outside. Take a look at your
Right.
See how the 3 is inside? So what you gotta do is you gotta hit the arrow once to get rid of it, and then you hit +3. So now it's outside. You now you gotta hit press. Okay. Yeah. You got it. So just make sure it looks just like the equation you got.
I didn't know that.
Yeah.
It was,
Okay.
okay.
Once you guys see that, it'll make it simple. Alright, good. Good, I've seen some good things. I'm just gonna sketch a few things up here and I'll let you guys finish.
No, we didn't see that. Good for you.
Hey, one thing I noticed, some of you guys you gotta pay attention to what's under the radical, okay? So when you type this in, you gotta make sure that it's outside the radical. So you hit the over arrow to get rid of it. You guys see what I just hit?
I know.
The over arrow and then -2. So now it's the -2 is not inside the radical. You have to know how to use your calculator. Alright, so all you do is hit that over arrow and then just hit graph. Okay, and so pretty straightforward. Second graph, there's our table. You want to go right to the air part and just start right after that. Okay, so like 0, -2 is pretty. 1, -1. Let's pick another pretty one. 4, 0 is nice. Okay, so it's just battleship plotting, right? 0, -2, that's your start point. 1 down 1, and 4, 0. And so there's your graph. Okay, so can you guys tell me, just from the graph, what's the domain just looking from the graph? So what are your x values? Greater or equal to what? 0. You guys know this is the x-axis, this is the y-axis, right? I'm hoping so. So when I'm talking about domain values, you're looking at what x values are used on the graph. Okay? Alright, what's the range going to be? So what y values am I using? So what y values, guys? All y values greater than -2. Okay? Greater or equal to -2. That's it. Okay, so you shouldn't have any issues if I asked you to graph those now. Okay, now remember, I could express this domain as 0 to infinity, and I could express the range as -2 to infinity. That's the same thing. Okay? Alright, the second one. Let me watch how I type this in, guys. I saw some of you guys doing the same mistake as the other one. Okay? So you do second x squared, x plus 2. Under the radical. Just that part's under the radical, right? The plus 3 is outside the radical. So all you do is hit the over arrow to get rid of it, and then hit plus 3. So now it's exactly the way that's written. And then hit graph. Okay? So the swish is going to start at -2 up 3. Okay? So on our table, if we go to our table, second graph, I'm going to go over to -2. That's our starting point. See how below, what happens when you go less than -2? It's an error because you'll start getting into negative square roots. Okay? So let's just copy some of these points down. So we have -2 up 3, -1 up 4, and then another pretty one would be like 2, 5. Plot your points, got your graph. So -2 up 3 is right here, -1 up 4, 2 up 5. So there's our graph. And there's our starting point. Okay? Alright, tell me the domain just from the graph. What would that be, Ashley? What's the domain of that one? No, look at the x-axis. Right? So greater than -2. Very good. So I'm using all x values greater to the right of -2. Including -2. Okay? Alright, what's the range? What would the range be, Lee, in this case? Okay, so it's above what number? Look at your y values, right? So it's above what? Above, no, on the y-axis, the y values. What values is it above? What value is this on the x-axis? 3, right? So it's all y values greater or equal to 3. Okay? So, like I said, you just got to look at the graph. You can see it from the graph, right? And so you can see, like, hey, there's the x values. That's how they're limited. You can also see how the y values are restricted. Very good. And so, remember, you know, to get that domain, guys, all you can do, you can take this under the radical, and you can easily get that part right away by doing what we did yesterday. By showing all the stuff under the radical has to be greater or equal to 0. Okay? So how would you get x by itself in that scenario? What would I do, Con? Subtract 2, right? So you guys see how you get the exact same domain if you just set the radicand greater or equal to 0. Okay? But we can also see it right from the graph by looking at the characteristics of that graph. Okay? Alright, last one I'd like to investigate, just real quick here. This should be an easier one to look at. What's this negative out front do to this? Yeah, well, yeah, so what do you mean by make it negative? So you type it in, there's the graph. So what did it do? It flipped it over the x-axis, yeah, right? So really, and you guys, let's not even plot this one. This is actually pretty easy to do, but what's the domain of that? Just looking at the graph. So anything greater than what? 0, right? All x values greater than 0 is part of the graph. Okay? What's the range going to be in this case? All y values, what? Less than or equal to 0. Right? So it's everything below 0 on the y-axis. Okay? So we're not going to kill this horse, guys. I think if you've seen a few, you should be able to do these. Okay? So what we're going to do is we're going to add to yesterday's assignment. Okay? So you have the assignment paper already. Alright? And so these are the problems that I want you to add to that assignment. And we're going to give you some time.